Answer the following questions about the function h of x equals negative x minus 5 quantity squared plus 5, and graph it on the plane below. All right, we have a lot of different questions here, all of surrounding this function. So domain and range. It's really best, I think, to get the domain and range from the graph. So let's hold off on those until we have the graph itself. Unless, of course, you want to go ahead and answer the domain. Because if you remember that the quadratic functions are all in a class of what are called polynomial functions, and all polynomial functions have a domain of negative infinity to positive infinity, you could go ahead and answer that. Increasing and decreasing, well, that's also going to be a little bit easier to identify once we see the graph. So let's hold off on that one. The vertex, that's a great place to begin. So the form of this function is a times x minus h quantity squared plus 5, whoops, plus k, where h and k are the coordinates of the vertex. Now, because of this minus in front of the h value, we need to take the opposite of the number that's sitting here. So the vertex is actually sitting at the point 5, 5. So we'll go ahead and plot that. 5, 5 is there. We'll just say that's the vertex with a V. And we'll go ahead and answer that. The y-intercept of h of x is located at the coordinates what? So the y-intercept. The thing about a y-intercept for any function is just the function evaluated at 0. So if I take this and evaluate it at 0, so h of 0 would be negative 0 minus 5 quantity squared plus 5. This would be negative, it looks like 25 plus 5, or negative 20. Now, most people think it's just the constant term in a quadratic, but that's only if you're in the form ax squared plus bx plus c. In this form, you do have to actually evaluate. So the y-intercept, it's not going to be visible on screen here because my scale only goes to negative 10. But we can state that the y-intercept is at the coordinates 0, negative 20. The equation for the line of symmetry. The nice thing about the line of symmetry is that for any quadratic, the line of symmetry is just a vertical line which passes through the vertex. So to make the equation of a vertical line, we just say it's x equals a constant, and it's whatever that y value is. Or, sorry, whatever that x value is, which is 5. So the equation is x equals 5. One of the x-intercepts of h of x is located at the coordinates, and we'll find that. So the x-intercepts, similar to the y-intercepts, they're involving 0, but this time it's where a function is equal to 0. So I take my function, which is negative x minus 5 quantity squared plus 5, and I set that equal to 0. The nice thing about solving this is I've already got it in the form of a perfect square, so I can use the square root property to solve this. So I just move the 5 over, so that would be negative x minus 5 quantity squared equals negative 5. Divide both sides by negative 1, which would make these both positive. Then I take the square root of both sides. So x minus 5 equals the plus or minus square root of 5. And finally, x equals 5 plus or minus the square root of 5. Now, where to draw these? That's kind of the trick. The best we can say is on our graph is approximate those values by taking 5 plus the square root of 5 and 5 minus the square root of 5. So at about 7.2 and 2.7 on the x-axis. So 7.2 is approximately right there, and 2.8, I'm sorry, I did not round correctly originally. So there are those zeros on my x-axis. To answer this question, however, we need to write these exactly and say it's 5 plus the square root of 5, comma 0, and 5 minus the square root of 5, 0. Okay, now we can see here that the parabola is going through these points here. So we can get a pretty decent sketch of this parabola at this point because we have a couple of points to work with. All right, so there's my parabola. And now I can go back and start answering questions like the range. The range is where the parabola is defined. So it's all the values from negative infinity up to this point right here, which is at positive 5. We're increasing. The parabola is increasing on this interval. So from negative infinity up to 5. And then it's decreasing from this point onward. So 5 to positive infinity. Now, the last thing is drawing the parabola. And that could be kind of tricky when you're doing this online. The reason that it could be tricky is because you have to plot the vertex and then you have to plot some other point. Well, the only other points we know that are actually on this scale, because we do know the Y-intercept, but it being at negative 20 is not very helpful. And these points actually aren't that helpful either because they're non-integer and it's hard to plot those in the computer system. So we have to find some other points that are integer based, and that's generally not too bad. What you can do is try and find a couple of points that are around the vertex, for instance. So if I were to take, say, positive 6 or positive 7 and plug that into the function, that should give me something. So let's use 7. So if I just evaluate this function at 7, so h of 7 would be negative 7 minus 5 quantity squared, and I believe it's plus 5. Let me double check. Yes. So this is negative 7 minus 5 is 2, so 2 squared is 4. So that adds up to 1. So that means I have the point 7, positive 1 on my graph. So 7, positive 1, if you'll notice, you actually got pretty close to that. That's that point right there. So there's an easy way of determining another point that you can use to actually make the graph online. So just then you would select the vertex first and then find the point 7, 1, and the computer would draw the rest of the parabola in for you.